Hey guys, in this video we're going to have a very quick look at what is a surd and give you a brief explanation as to what a number means when it's expressed in the form of a surd, and hopefully it will give you a better understanding when using them in algebraic equations or in complex mathematics. So from a previous video you should know that in mathematics we've got real numbers, and then real numbers can be broken down into rational and irrational numbers. So real numbers broken down into rational and irrational. And here we're going to be primarily focused on irrational numbers. Irrational numbers. And an irrational number is a number that cannot be represented in the form a over b. If you were to represent them in a fraction, in a decimal, they'd be never ending. There's no way to represent them as a whole number, or even as a fraction or a decimal. So that's basically what an irrational number is. Now, another concept to just be aware of is that in mathematics, when we multiply two numbers together, 2 times 2 for example, this is an operation, multiplying it by itself, 2 squared, and we can equate this here. 2 squared is 4. Working backwards, this same process is known as taking the square root, which is also equal to 4 to the power of a half. And we know that in this case, the square root of 4 is the same as the square root of 2 times the square root of 2, or root 2 times root 2, which is root 2 all squared, which is 2 to the power of a half all squared. And then using our index laws, which we've also covered in a previous video, this comes out as 2 to the power of a half times 2, and a half times 2 is just 1, and 2 to the power of 1 is of course 2. So we know that the root 4 equals 2, but that's something you should have already known. So let's continue with what we're saying. So taking the square root, in this case, is the reverse operation. These two things are the same. We get back to our original number. So a surd is any number represented by a square root symbol, but not always can we simplify this down to an integer. For example, let's say we have the number root 2. This number cannot be represented by integers or even by a rational number. In fact, the solution here is an irrational number. In this case, we knew that multiplying 2 together with itself will give us a total of 4. Whereas in this case, like I mentioned, there's no way to reduce this down to an integer or a rational number. So the solution here, root 2, is 1.414213562337, etc. You get the point. But this is a never-ending number. So in mathematics, when we're working with irrational numbers, it doesn't make a lot of sense to represent the number in this form. Sure, you might be able to leave it with dots at the end to indicate that it's not the end of the number, and you could approximate it to X number of decimal places, but you're going to lose some rounding as you work with it, and it's going to be very messy as well. So often in mathematics, we represent numbers like this, root 2, just as root 2 in its simplest form. So this is known as a surd, and surds are another aspect of algebraic equations or often are introduced in algebraic equations and used with different number calculations. There's several different operations that you can use with surds, so it's almost another aspect to consider when using different mathematical operations. So just something to be aware of at this stage. If you didn't know what a surd was, this is basically it. And in one of our next videos, we'll cover some of the different simplification techniques for reducing surds to their simplest form and why that's important as well. So thanks for watching. Hope you enjoyed, and we'll see you in the next video. Bye.